Okay, this is a scuba regulator. This part here goes onto the bottle and it fits over with this A-frame here. You undo this, that makes a seal, and the screw pushes it on. There's another better way of doing this called the DIN, which is like a screw that goes directly into the tank itself. Those are two common, A-frame and DIN connectors. We'll talk about those later. The 240 bar pressure air goes in here, 240 times normal pressure. This reduces it to about 10 bar in these hoses called the medium pressure hose. It goes down the medium pressure hose and it goes to a primary regulator, which is what this is, or an alternative air source, or an octopus, which is what this is. This is a simple, cheap little one. Inside here, there's a diaphragm, and that leads to a lever. So when I breathe in, I only have to breathe in gently. It cracks open this valve here and supplies me with as much air as I want. Now this is for on-demand air. The other idea I've got, we could put another port in here, or we could connect to this high pressure hose, as medium pressure hose here, and we could connect a little converter here that lets us take 10 bars through a valve down to atmospheric pressure and to an oxygen mask. But for this first method, what we get here is this is an oxygen pocket mask. So it's used to seal around the face as opposed to your normal mask or non-rebreather mask, which allow air from the outside in. And then what we can do is I've taken this little piece of kit here. This is meant to hold one of these regs onto your BC until it's ready for emergency. But I realized that if we took this or something similar, we can cut a hole in it, we can put a cable tie around here, and we can do this. So normally this thing is called an octopus holder, or scumball was what they were originally marketed as. We cut the hole in the bottom here, and it means we can fit the oxygen mask to this. Now if we hook this up to a diver's compressed air tank, but instead of using compressed air, it's breathing 36% or 40% oxygen. Now anything that touches more than 40% oxygen has to be oxygen cleaned and then serviced, use special O-rings. But we could just use straight tanks with less than 40% nitrox, as that's called, and that would be can be used as is. And if you're using a normal free flow mask, with 4 litres a minute of oxygen, you're only getting about 40% oxygen anyway. Now, so we could use that 40% oxygen mix already in a tank and supply it to somebody with this regulator. That's it, that's the only piece you need. But if you got yourself a regulator that was oxygen cleaned, you could take this valve here, clean any grease from it, put some extra O-rings in it, and the same goes for this bit here. That would take about an hour. And if we put it then in a tank that's been oxygen cleaned and oxygen serviced, again about an hour, we could supply 100% O2 like this. Another way of doing this as well is we could crack this valve so it's in constant free flow, and maybe put something on here, a screw, to push this down and adjust how much free flow there would be. So we could also make it interface with standard oxygen masks. Now this is a standard scuba tank. This is 12 litres in size. So this is a 12 litre one on the right, and there's the 15 litre one on the left. This one holds, the one on the left holds over 3,500 litres of air if we were to let all those litres out of there. It's a 15 litre water capacity. That means how much water it could hold inside, and we squeeze 240 times that into there. So 15 times 240. This is 12 litres times 240. So this will last approximately 3.5 hours at 10 litres per minute. Breathing rate down to about 2 hours if somebody's breathing faster on the surface, and this will last up to 5 hours if somebody's breathing through the system I'm about to show you. Could be less, could be 3 hours. Now this tank valve, this is the thing that needs to be modified. Very little. All you have to do is to make it above 40% oxygen. You have to take it off, pull it apart, clean it, degrease it, and put a couple of new O-rings in. and then it's ready to use for full oxygen service if you want to. Now this one has an insert here. That insert comes out and it leaves a female DIN connector there. So again, we could use an A-clamp or a DIN connector and an adapter to the oxygen A-clamp. The Scuba A-clamp just sits over the top like this. We just tighten that up, and that O-ring in there makes a seal. And what we do, we turn that on, we turn our gauges away from us. And now that I haven't turned it all the way on for now, but if we take this regulator, as I said, I've got 200 bar in here, 200 bar in here, down to 10 bar in here, and this takes it down. When I push this button, it'll free flow. And when I put it in my mouth, and you see it just breathes as you. And if I use the higher performance regulator, this one has inhalation adjustments, Venturi assist here, that'll make it breathe even easier. You barely need to breathe in at all. It would, of course, this does need a little bit of breathing inspiration, but once it's actually cracked and open, it breathes quite easily. So it would be used more for a patient who is needs oxygen but is still not restricted in the breathing. Constant flow is the next thing we do, where we might be able to adapt this to flow. Maybe a screw that pushes on here and keeps it down, and then that would provide flow to an oxygen mask. But when we put this on the regulator like this, then we should be able to see, and I don't know how well because I can't do a selfie on this now, but you should see. No, I'm not working there a minute, hang on. Okay. At the moment, because I haven't glued this thing together, there are too many leaks in it to actually work. But again, if we made it constant flow, so what we'd have to do is to push something onto here, again with a fixed screw. Although once this is all sealed up, it should just breathe in normally. But the point is, this is just a very rough mock-up I've done in 5 minutes. The concept is there to provide O2 using the stock of divers tanks that is available in private hands, and people will be able to lend them with the aim of getting them back. And if not, get a voucher to get equivalent later on. Various ways could do that. I'm sure a lot of people, if things get bad enough, a lot of people will be willing to donate.